Hi everyone. We are from Group 5 and today we are going to review and discuss Chapter 13, which is Lateral Earth Pressure. So maybe Dinesh can start by learning objectives.
Okay. Lateral earth pressure is a pressure that soil exerts in a horizontal direction. So according to the learning objective, first we're gonna understand the condition leading to at rest, active and passive earth pressures. And then we're gonna see how to determine the at rest earth pressures, and then also we're gonna learn about the pressure at rest for partially submerged soil and more others. Okay, let's move to the first slide. Okay. The magnitude of lateral earth pressure depends on the shear strength characteristic of soil, beside lateral strain condition and pore water pressure. In addition, the state of equilibrium of soil and the wall surface area also include in the magnitude of the lateral earth pressure. Okay, lateral earth pressure are the direct result of horizontal stresses in the soil. Okay, next slide. Okay, in order to understand the lateral earth pressure, we have to define the coefficient of lateral earth pressure, which is K. The formula will be horizontal effective stress divided by vertical effective stress. That is the KO lah. Okay, next.
That is the coefficient lah.
Yes.
Faham.
Right. Okay.
So actually there are three states of lateral earth pressure. For example, at rest, active earth pressure and passive earth pressure. Okay, next slide. I think this is also explain about the formula for active earth pressure, is it? Ka and Kp.
Yes, sir.
Okay. Before that. Okay, I explain about the at rest first lah. At rest, the pressure will occur when the earth pressure occur when there is no wall rotation. Active earth pressure occurs when the wall tilts away from the soil. This one also the KO lah. I think this is another formula to identify the coefficient of lateral earth pressure. This one earth pressure
You
at
want to
rest,
change
right?
the slide?
This one we need to
Yeah.
identify the value of force, right? Force per unit length.
Pressure, force per
Ah.
pressure.
Pressure. Force. This one force. The total force per unit.
Total force.
Okay.
Total force per unit length.
Yeah,
So
equal to
we can
half
see
times.
as coefficient just now, KO.
Coefficient. Times gamma.
So
Gamma,
the force increase as the height decrease, is it? Sebab bawah ni lagi besar kan?
Ya betul.
Bawah ni lagi banyak force lah.
Betul.
Alright, next.
Okay. Yes. So this is for the earth pressure at rest for partially submerged soil. So at the top of the soil, there is no compensating water on the other side of the wall. So the lateral earth pressure at rest can be given as
This formula.
Yeah. Anyway, there's a different formula, but it doesn't show here. In the mind tab.
Oh, it has
Siapa ada buka
another.
mind tab sekarang?
Okay.
Another formula.
Oh, another to find?
To find lateral earth pressure yang kat atas.
Oh, this one for effective stress for horizontal, right? This equation. Kan?
Betul tu.
Kira yang lagi satu tu
So dia
untuk
macam
apa?
lagi
Maksudnya kita
satu
cari
tu,
ini dulu. Lepas tu baru substitute value dia untuk dapatkan
Betul.
force tu.
betul.
Sebab dia bahagi-bahagi part tu kan.
Macam mana?
Okay, cuba scroll balik atas. Tak silap aku. Scroll balik atas. Tapi dia ada satu lagi equation. Mana? Stop. Laju sangat ni. This one, kita nak cari yang tadi equation dekat bawah tu, kita nak cari effective stress horizontal. Sebab dia dekat submerge punya. So equation dia, like ada satu equation. Faham tak? Panas je lah.
Tapi tak ada dalam slide ni.
Betul.
Ha.
Dia macam dia ada kat mindtab. So macam tapi to simplify lah, macam doktor bagian tu lah untuk formula kan.
Untuk cari effective stress dekat horizontal H ni. So once kita dapat ni, kita masukkan balik dalam equation. Kan Farah kan?
Betul tu. Apa yang aku faham lah daripada aku baca mindtab tu lah.
Dia nak cari apa sebenarnya Farah? Kalau kita gunakan
Dia
effective
submerge
stress.
dengan tak submerge tu ke?
Macam dia nak cari yang belah atas dengan belah bawah juga. So macam lain-lain kan. So macam yang tu, yang belah bawah dia kena tambah dengan saturated unit weight of soil tu.
So lah dekat gambar tu dia macam dia bagi tahulah dekat gambar Raja B tu. Tu. Tu sebab tambahkan.
Okay. Nanti kena check balik mantap.
Okay, next slide. Okay. Okay, so yang ni lateral pressure on unyielding retaining walls from surcharge. So ada 3 surcharge. First point load surcharge, second line load, third strip load. So yang strip load tu actually maksud dia term strip loading tu dia actually used to indicate a loading that has a finite width along the x-axis but an infinite length along the y-axis. Maksud dia lah aku rasa macam kat y-axis macam dia tak kira, tapi dia actually kira yang dekat x-axis je. So macam dekat strip load tu kan macam ada macam box kan kat belah atas kan. So macam dia kira yang x-axis je lah, tapi yang belah sana tu dia tak kira. Yang tu.
Dia kira lintang ke bawah?
Macam tu lah. So yang lain tu macam formula-formula dia je lah.
Okay. So next part. Kan? Okay, so next is Rankine theories. So in this part, we are going to understand the theories of active and passive pressure, and we also going to look at the states to apply a wall of limited height. Apply the Rankine's theory for a wall of limited height. Okay, so as I've mentioned before, there are two theories involved, which are active and passive. So in active, when every point, in active, it allows the wall to move away from the soil mass, will gradually decrease the horizontal principal stress until failure. So this situation represents Rankine's active state. Meaning, if this is our soil mass, it will move away from the soil mass. Next is passive pressure. In passive pressure, it is opposite from active pressure. So it says here, in a Rankine's theory of passive pressure, it pushes the wall into the soil mass, and gradually pushing the wall into the soil mass will gradually increase the horizontal principal stress until failure. So this situation here shows the Rankine's passive state. Right. So this is the condition where we have different height of wall. So depending on the direction of a wall yields, the soil may reach either Rankine's active or passive state. So imagine this is our wall. Kan. So it can, dia boleh jadi dua situation. Either it will be active pressure or passive pressure.
So yang A tu aktif lah.
Aktif
Gambar tu.
Yeah, active because
Sebab
it's
dia
moving
move
away
away
from
kan.
the soil.
Okay.
Betul? Betul?
And then be passive. Kan.
Betul.
Betul?
In Rankine, active and passive pressure with sloping backfill. If the backfill slopes at an angle A, the active and passive pressures will also be inclined at an angle A from the horizontal. From a backfill made from a granular soil with C prime equals to 0 because it is right hand, so memang C equals to 0 lah. From there we able to find the stress A by using this formula.
So backfill yang atas ni kan,
Yes.
fill ni kan.
Hmm.
So this is the formula.
This is the formula for constant for A lah. Okay. The coefficient.
And depends on whether it is passive or active lah.
There's two different formulas. For active pressure, the formula is above given. The second one for the passive, the below one we have to use. So first we have to identify the active and passive first lah. Then we have to input the formula.
Just different sign je. Yang plus dengan minus tu je.
Yes.
I think so.
Diagram for lateral earth pressure distribute against retaining walls with vertical pressure. Figure 13.16 on the right shows the distribution of pressure for a coinsular soil with a horizontal ground surface. Okay, that is the A, I think, the diagram, and it also shows the shape of the failure wedge for the active and passive cases. So from the diagram, we are able to see the failure for the active and passive.
So sekarang ni ada distribution, pressure distribution kan, condition dia.
Pergi atas nanti.
Ni.
Okay. Next slide.
Alright.
So this is diagram
for.
Continue.
No. Yelah, this one for partially submerged. Kan?
This one for
Because
submerged.
we have different states of soil, so we cannot do same triangle like this. So kena bezakan kan macam ni.
So basically ini maksudnya explanation based on Farah tadi, tapi
Farah
dia
tadi.
dia secara mendalam sikit. Kan?
Betul.
So basically untuk lateral pressure ni dia ada dua teori. The first one tadi yang Nabil explain tu, yang Rankine theory tu. Another one is Coulomb theory. So based on apa yang baca dekat MyTab, kalau Rankine theory ni dia consider the equilibrium of the soil. Kalau Coulomb theory dia consider the equilibrium of sliding wedge of the soil in the backfill. So ada, dia orang punya teori tu ada different sikit. So mana tadi? Okay, kalau kita tengok dekat Coulomb theory ni, basically kita nak determine force juga, force per unit length of the wall. Tapi cara nak calculate tu yang different. Okay, dekat sini, okay turun bawah, tengok formula.
Next slide ke?
Next slide ya. Untuk Coulomb active pressure, kalau kita nak determine the force per unit length dia, this one the equation that we use for the Coulomb active earth pressure. Yeah. PA equal to half times KO aka janganlah okay sini stop. Okay stop. Okay.
Sorry.
So kita
Learn
nak
slow.
determine. Okay tak apa. So kita nak determine the Coulomb active pressure guna teori ni tau. So bila nak guna teori ni which is equal to half times Ka gamma times H2. So kita bila nak gunakan untuk determine the pressure, pressure pula, force dia guna Coulomb theory. So kita gunalah equation ni, but untuk determine the coefficients of active, kita tak guna yang biasa tu, apa tadi? Effective stress horizontal bagi vertical. Tapi kita guna equation yang ni. Faham tak?
Oh, faham.
So once kita dapat coefficient ni, kita substitutekan dalam ni, so kita dapatlah. Maksudnya dia based on condition question tu. Kalau question direct, so kalau dia bagi effective stress horizontal dengan effective stress vertical, so kita boleh terus yang bahagi tu je. Kalau dia bagi condition yang kalau dekat figure atas tadi tu yang ada angle semua, so kita guna equation yang ni. Okay. Turun bawah.
Tapi
Okay,
ada
next slide.
dia akan
Apa?
kebarangkalian dia akan stick ke Coulomb or retain apa tu dia satu tu?
Retain.
Macam
ya.
nak guna mana satu lah.
Dia ada kebarangkalian untuk stick ke tak ada? Tak sure. Dia
Ada.
memang ada.
Tapi kalau
Dia-
dekat MyTab ni macam ada.
Adalah sebab dia takkan terus bagi kita just gambar untuk buat-buat terus kan.
Tapi
Dia mesti
basically
stick
sama
kan.
je.
Okay.
Itulah teori je. Okay, the second one is Coulomb passive pressure. Sama juga equation dia half time Kp gamma time H to the power of 2. So beza dia dekat coefficient ni lah. Kalau passive, dia punya Kp dia untuk passive, coefficient dia 1 minus. Kalau active, 1 plus. Kalau tak percaya boleh scroll balik atas.
Percaya.
Percaya.
So macam tu lah kalau nak calculate untuk apa ni force dia. Okay, next. Oh okay. Yang ini in case kalau ada condition which is earthquake forces, maksudnya ada forces lain. So kita guna equation yang ni. Okay. So half time gamma H to the power of 2 1 minus kV. kV ni adalah vertical component of earthquake acceleration. Tak tahulah kalau dalam equation tu dia bagi value tu ke
Bagi
ataupun
tiga
kita
kan?
need to identify. Tapi kalau kita identify, kalau tengok dekat MyTab tak ada pun equation macam mana nak identify vertical
Identify
component.
dia kan.
So mungkin dia bagi ataupun contoh. So substitute je. So kita dapatlah force dia.
Force tu.
Yang KH bila kita akan guna? Horizontal component.
Okay, for KA, which one? KA this one ke?
KH.
KH.
Horizontal tu.
KH tak guna. Tak ada pun dalam equation. Tak ada KH. Okay,
Ataupun
satu lagi
dalam
untuk
ketika dia bagi horizontal component kena tukar KV ke KH ke macam mana?
tu tak tahulah tak sebab tak tengok equation.
Pergi carilah sekarang. Main-main je.
Amboi. Nanti tengok pada equation.
You nak
Tapi dalam
cari.
MyTab tak ada equation yang macam tu, dia macam selalunya macam dekat MyTab dia macam bagi value. Okay, dekat sini kan 1 minus kV ni times K tanda 2 ni A. Untuk identify the value ni ada ada apa ni untuk identify the value KA ni ada equation dekat next slide. Cuba turun. Next slide. This one equation dia. So nama
Mononobe
Apa
Okabe.
nama equation itu?
Macam nama Naruto.
Can you please pronounce?
equation. This one lah.
Okabe.
So itulah equation dia. Tapi untuk beta bar ni, this one equation dia tan to the power of negative 1. So KH, ni kita guna KH. Bagi dengan 1 tolak KV. So kita dapatlah beta bar ni. Substitute lah dalam value ni. So dapatlah nanti cap equation ni. Cap equation gitu. Faham tak?
Faham.
Kejap lah, ada satu lagi dekat bawah ni. Kalau kan? Kalau
Okay.
once kau dapat, dengar ni, kalau once korang dapat beta bar ni equal to 0, maksudnya this equation reduce to the equation for Coulomb active pressure. Maksudnya tak ada force tu.
Tak ada force.
dapat kosong. Nanti kalau masukkan kosong nanti dapat kosong. Okay, dah.
Oh.
So sebab kalau once korang dapat
Dah
time
ke?
tu dapat zero. Dah.
Nanti kejap. Pas tengah nak discuss tu.
Okay.
Dapat time je. Okay dah cukup itu je part saya.
Okay.
Aduh. Okay, aku sambung Okay. Okay, for the common type of retaining walls in the field, kita ada dua kategori, which is rigid retaining walls and mechanically stabilized earth MSE walls. For the rigid retaining walls, include gravity, semi-gravity, cantilever, and counterfort retaining walls. Okay, next slide. Okay. For the gravity retaining walls, korang boleh tengok gambar dekat yang A tu, yang first tu. Dia construct with plain concrete or stone masonry. Untuk semi-gravity walls pula, they use a small amount of steel and small gravity walls tu, they resist external loads. Combined dengan resistance offered by safety of structure, vertical soil component of weight above the footing. And then for the cantilever retaining walls, made of reinforced concrete that consists of a thin stem and base slab. Apa tu namanya? The base tu they divide into two parts, the heel and the toe. The heel is the part of the base under the backfill. The toe is the other part of the base. And then for the counterfort retaining walls, similar macam cantilever juga, tapi dia lagi kecil.
Stabil. Kecil.
Apa? Dia kecil. Kecil, and then slab, vertical slab tu then known as counterforts tu lah, that tie the wall and base slab together. Counterforts tu reduce the shear and bending moments. Next. So for the MSE, which is mechanically stabilized earth, main components dia ada tiga. Backfill, which is granular soil. Main reason for using granular soil ni sebab it does not retain water. Maksudnya dia ada small void ratio. And then typically backfill ni use untuk kekuatan dia dengan support a structure lah. Sebab tu kita kena tahu yang fast cari-cari tu kan. Dia ada kena dengan backfill juga tadi. And then reinforcement dalam backfill tu sebab nak bagi dia stabil. And then also a cover or skin on the front face. So these walls are flexible and are recently being used more commonly. Last slide. So for the summary, as can be seen yang Dinesh dah cakap tadi, at rest earth pressure, no rotation. Also, the wall does not yield toward or away from the soil. Untuk active earth pressure, wall rotates away from the soil. Passive earth pressure, wall rotates towards the soil. For the Coulomb analysis, count for friction between the soil and the wall for the active and passive pressure. Coulomb's active earth pressure may be modified to account the earthquake forces. And then apa yang aku dah cakap tadi, kita ada dua type of retaining walls, which is rigid and mechanically stabilized earth walls. Itu je.
Alright.
Faham? Okay.
So I think that's all for this topic.